All right, hello everyone and welcome to Handmade Hero Show, where we code a complete game live on stream. We are going to try to do some more useful stuff with our lighting today. If you remember from yesterday, we were taking a look at the Raycaster, and we think we've got it a little cleaner now. We just hadn't used it in a while, and we'd made a bunch of changes to it, so we had to kind of make sure it was still running okay. And it seems like it's at least functional now, and we probably still have some more debugging to do because, we didn't really do much to ensure that it was working properly, but we did get it basically to the point where we think it's sort of doing something reasonable. And so before we go any further, we want to try doing the next thing. You can notice we're still getting all these pockmarks here, but I think a lot of that has to do with the way that we're doing the placement of the raycasting and the way we're doing the interpolation. So I'm pretty sure that that's not really a concern at the moment. So what I'd like to do now is take a look at doing the raycasting from actual proper locations. And then after that's sort of working more correctly to my satisfaction, then we will move on to debugging the raycasting further, assuming that we see evidence of further errors. Because at that point, I think we'll be able to see errors more cleanly. So what I'm going to do, what I'm going to start with, is I want, and I probably shouldn't have closed that because I do want to mention one thing. So what I want to do now is, if you look at these, these little cubes that we've placed throughout the environment here, those cubes are the light probes. They're not placed in any particularly interesting way at the moment. We're just putting 2 per room cell. And all I really want to do here is I want to take those light probes and I want to use those as the source locations for our lighting raycasts, right? That's all we're really trying to do here. And the reason I want to do that is because if you think about the way that we're actually creating our lighting, we have a voxel grid that we're interpolating the lighting results on, and we really don't want to cast, like this test program, this test version right here, is casting from the centers of the voxels. And you can see that if I zoom in here, you can actually see we drew this out. You can see those lines all over there, right? So you can see like it casting from here, and oh, it can hit the light source. So over here it will write like, okay, there's light here, right? But in other places it can't hit the light source. So for example, if you look, like this one down here is coming from beneath the floor, right? So down here it's going to say that it can't hit the light source or whatever, right? And the problem that you have, so just thinking about, right, if you're looking at how this is going to work, the problem that you have is that if you place these things such that they're underneath the floor or whatever, and you have like one above the floor and one below the floor, like is what will happen in this case, then you will get this irregular pattern. And again, if we had actually run the full lighting bounce stuff, this wouldn't be as bad because you would have things probably diffusing more, but it's still a problem because basically you're taking samples from places that are inside geometry, and that will always make our lighting solution worse because it means that we'll be interpolating to black in a bunch of places where we shouldn't have been, right? And there's things that we can do to try to mitigate that, but what we'd rather do is just never have that problem. So what we want to do instead is say, yes, we are interpolating lighting at voxel centers, but we don't actually want to take the shadowing and transmission vectors from those centers. We want to take those from places in the actual world that we know are valid and then spread them out to the actual voxel centers for interpolation later. That's what we actually wanted to have happen. And so that's what we need to start working with here, and we're going to start doing that now by trying to take these light probe locations and using those as the places that we cast lights from. So in the lighting solution itself, what we need to start doing is when we do our compute light propagation, well, although I guess it's not technically in here because we're sort of doing the non-propagation version right now. We're just kind of got a hard-coded one here that we're working with. And that's because we don't want to actually have to do propagation yet. We're just trying to do single ray check. And this is, again, for debugging purposes. Before we start convecting light around and it becomes really hard to tell if things are working, we want to get it working in a more easy to spot case, right? So if we now go to the Raycaster and we take a look at what's happening here, you can see here that we're raycasting from voxel centers, and that's not what we want to do. And so what I'd like to do is take this right here, which is, you know, this thing that sort of raycasts from the voxel centers separately. I want that to sort of go away now. That needs to now be just test code, and we need something that's going to do a loop over the actual light probes instead. And so if you take a loop at what we've got here, I believe we can just get this. This is just something that we pick up as part of the initialization procedure. So I believe when we do begin lighting computation, I believe we need to store that. And I don't know if we're storing it yet, right? I don't know. Just looking here. It doesn't look like we're actually putting anything in there yet, right? So if we go in here and we look for light probe P or light probe count, I don't actually know if anyone's doing anything with that. So if I go through and I do light probe count, so we are, okay, so right here, we do grab it. So this is what we need. We've got a count of the light probes in the system. We have their locations. And that's all we need. Eventually, we won't even really need to do it this way because eventually the light probes will just be stacked in here. Because previously we thought we were going to have to save them and actually communicate about them across frames and to the GPU. We don't need that anymore. We're just using them as raycast locations. And so it's gonna get even nicer than this in the future. But it will still boil down to the same thing, which is a count and a P. It's just they won't have to come from an expanding buffer with pre-assigned indices. If you remember correctly, back in the world import code, we got a bunch of nonsense going on now. That's this stuff, right? This will hopefully, if I'm right, and we get the lighting working the way that we're trying to do now, if this works well, that can go away, which is great. It's a whole bunch of bookkeeping that goes away, less possibility for bugs, less runtime costs and everything. So it's just an unalloyed win if we can actually make it work without stable indices across frames. I mean, generally speaking, anything you can make work without stable indices across frames accelerates it usually. Usually. So anyway, going through here, taking a look at this. So what I want to do is I want to loop over these. So we kind of want to take this out of the equation here. And because we're kind of starting to stack up a little bit too much in here, I'm going to start pulling these out just because, as you know, I like having things written in line, certainly. But I don't like it when I've got too many things turned off, right? Because then it's hard for me to read the code. So what I'd like to do here is just grab this whole bit, which is all stuff we were using to compute that lighting. And I'm just going to go ahead and pull that out into a function here. And I don't really care about it at the moment, so I'm just going to have this be like something like this. Maybe gawk. Yeah, frumbledygawk. That seems good. As opposed to gobbledygook, it's frumbledygook. You know, makes perfect sense. So anyway, in here, I'm just going to say, look, there's some stuff, and we don't care about it right now, but I want to save this routine in case we ever want to rerun just that version of it where we're casting from the voxel centers, right? So then I want to do another version of this where we're going to sort of do similar code. So I'm going to copy it, but we're going to gut most of it and do it sort of a little bit differently. So we're going to come through here, and instead of looping over the voxel with these X, Y's, and Z's, I'm instead going to take this, and I'm just going to loop over the light probes. Like this. So we're going to say for every light probe that we know is in the system, like so, we're going to do some stuff, right? So we're going to take our light probe. We're going to do the test casting here. We don't care about the Vox Center P anymore. Right, that's not a thing. We do maybe want to do this stuff still, so we'll see. So this will maybe be probe P here, right? So we are going to still do the rest of this stuff, and maybe we even do all of this the same way, right? But otherwise, no. And then, yeah, like in here, our isTestCast is probably not really going to be able to do quite exactly what it was doing here, but we probably do want an isTestCast thing. So I'm going to get rid of these for now, but I'm going to leave the isTestCast concept in place. We're just going to say it's not a test cast all the time. And in the future, we're going to do stuff like maybe isolate by index or by distance from the light source or who knows what. So we're still going to do this, but now instead of Vox Center, we're going to do like probe P, and then we're going to go through and do all this nonsense exactly the same way. And then we're still going to want to do all this. Don't ask me why I didn't just search and replace that, but I didn't. Oops. So here is our thing for raycasting the light probe, and then we know, what we actually think the light probe did. And then when we get into here, we can still compute all this stuff effectively the same way, but then the problem that we're going to have, and the part that's the actual new code that we have to write, because the probe P will be very easy for us to compute, right? We know that the probe P is really trivial because we have an array of probe Ps. So if we look at what's happening here, right, it's just that for whichever one of these things we're looking at. So we can pretty much run the exact same raycasting code to raycast from each one of those probes. And the problem that we're going to have at that point is just we don't know what to do with this. So the X, Y, and Z locations inside the voxel that pertain to this particular probe, we have absolutely no idea what the heck would actually be here, right? So we don't know the answer to this particular question. And furthermore, there's a couple other things that we don't really know. So if you take a look in here, don't really know, but there's some other things that we might not really want to have happen. So for example, if you take a look here, there's the light normal, which is this thing. But if we're imagining that these lights have like a radial fall off or anything else that we might want to include into the lighting computation that takes distance into account. And when I say lighting, of course, here, I mean artistic lighting. This has nothing to do with real light. Real light doesn't really have distance fall off. What it has instead is an inverse square law that has to do with the diffuse reflection. And that's just based on how the photons spread across whatever it's going to bounce off of. So technically, for a specular reflection, there would be no distance fall off. For a diffuse reflection, there'd be inverse square fall off. This game is not about simulating realistic light, so we're probably going to want what would amount to be a programmable fall off, right? We're probably going to want to have something that an artist tunes, or in this case, we're going to tune it, and so on. And so what we want to do here is we want to go and we want to basically produce something usable, not something physical, right? So we don't care too much about physical simulation of the light here. What we care about is us getting good results out of it. So we do want some fall-off equation in there. We don't necessarily know what it is, but what we do know is that if we're putting an interpolator down at a particular point, we probably want this distance function here that we're using to be based instead on something based on the voxel center we write to, even though we're raycasting from a different location, right? Which I realize is a little bit weird. But so things like the light normal might want to be recomputed, if that makes sense. And things like this light DF maybe want to be recomputed. So there's that, right? So I'm going to change this around a little bit and do it slightly differently in the future. What we're going to do here is we're going to move this down here, right? And this stuff is going to be computed in probably a very different way. And we're maybe going to use the shadow as a Boolean to like modify it or something, right? So just get yourself in the mindset of what we output to the voxel may be computed at voxel centers to improve our interpolation quality, even though the raycasting that we do that controls whether or not things were shadowed is not going to work that way, right? So these are going to be separate things. And so if we take a look at light N here, I probably want to separate this stuff out, again, like I was saying. So this stuff might come down here and be computed in a different way. So we would compute the light N, and this probe P here might actually be Vox center P still, right? So this might happen the same way. And this stuff might be based completely differently. So for example, we don't need to normalize this here because the light, well, actually, no, we do. Never mind. That's happening here, right? So we do want to compute this stuff, and then we want to stuff the voxel here. And this is going to be inside some kind of a thing that works with the voxel. But what we're actually going to do for the casting is we're going to have a separate set of things. So here we've got the probe P, which is not going to be about the voxel center. We're going to have the, like, the cast direction or something happening here. And I don't actually know if there's any reason why that has to be normalized, to be completely honest with you. I don't think that it does, since we're not actually doing something there. I may normalize it here just to start with, but we'll probably pull that out. And the light distance stuff here is really just to figure out whether we hit anything. And we wouldn't really need the length. We could just take the inner product, right? So we can do a lot of stuff here that would make this cleaner than it's going to be right now, or not cleaner, but simpler, faster. We just don't care about that at the moment, right? So what we want to do here is say, like, this is basically a Tmax value. So when we take this, when we take all this stuff, what we're really producing here is a Tmax value. When we come through here and we place the cast D in there, and maybe these should be written the other way. Maybe I should write this as like that, right? So this is the casting location. So we have a place we're casting from. This is the place we're casting to. And this is the direction that we need to cast in, right? So then we come down and we're going to do our raycasting. We have our probe P4 and our light N4. This is going to be cast P. This is going to be cast D. And after we're done with that, we get back our cast result. This is going to be our maximum, which is how far it took to get to the light source. That's going to tell us whether or not we hit anything. From then on out, we're using the cast location to recompute this here. This is if we didn't hit and we want to draw the thing anyway. In fact, this, though, you could just use the light P, so I'm not sure why we did that exactly, but probably just for further testing cases, right? But you can see that we wouldn't actually have to do that, right? This is not cast P. This is like result P, right? Or hit P. There we go. Hit P. Right, so that produces the hit P that we actually want to use. And then from here, we would just, this would all be cast P, cast P, cast P. So that keeps that piece of code as sort of doing something in a separate way. This light N, light C0 stuff, that's going to get computed kind of down here instead. So that's just going to be this stuff. And now I think we've sort of cleaned ourselves up to the point where we could call this something, right? This is going to be like test cast from probes, right? And we're going to want to pass the lighting solution in here, like so. And then we're going to have a few problems. We also need the commands there. So this stuff. Oh, wait, no we don't. That already got assigned. So all we really need now is to deal with the voxel stuff, which is not going to be correct, right? Oh, and of course the light P. So that actually is a debug thing that we're specifying, so that kind of has to come in to the equation. I think it's just debug light P, though. We don't really adulter that at all, I don't think. Yeah. So we don't really change that, so I'm just going to go ahead and say that that's just something we pull out here. So, okay, that's the, like, test casting direction. And then we have to have the dummy work order because we're not actually multi-threading this yet. So we're really just doing sort of a nonsense raycast version. But because the raycaster is set up to run on multiple threads, it needs a dummy work value to make it go. All right. So now if we clean up what we've got here, this light disk thing here, this just Tmax is what I decided to call that. When we actually do this stuff here, this Vox Center P is what we now need to figure out. And furthermore, we actually need this stuff to work as well. I think that, though, gets us down now to where we actually want to be. The rest of the stuff is stuff we now have to actually fix. And if we go and call this now, we can insert that call right here where we were doing it before. I also don't think this needs to be here because no one's raycasting anymore. So we should be able to just have now an entirely functional program that just needs some way of spreading this information out to nearby voxels. And so that's the next thing that we have to do. So, well, yeah. So in order to do that, we now need some way of figuring out where one of these things actually is, right? And if you look at our spatial index nonsense that we had before, we sort of had ways of doing that. We could say, this is exactly the sort of stuff we need, where it's like, tell me for a particular location, where it was, and we had a way to index into the voxel and all that good stuff, right? And that's pretty much what we actually need to do now is, this code is not necessary anymore, and we can delete all of it pretty much, except for the mapping into the grid part, right? Because this is exactly what we actually need to do now. So what we want to do is have some way of reconstructing this part of the code that we sort of sketched out before, but now using, just our basic voxel information that we have. And you can see we've got some information here about it, like the inverse voxel cell dimension and stuff like that. So we should be able to now have this go directly to the information that we need. So let's say that we've got a V3S here. I don't know that we're ever going to need the UVW. I just don't think that's going to be relevant, because what we're going to want to do is recompute the solutions at the voxel centers and just use the raycast. So I don't, yeah. Anyway. So what I want to do here is say, look, here's a lighting solution. Here's the p-value that's like some point in space, just any world space point. In fact, I'll just call it world p. And what I want to do now is I want this thing to produce, using this information, right? I want this thing to produce where in the voxel this raycast actually is, right? So when we do that, what we need to do is we need to do exactly the same steps. The first thing we need to do is get the floating point coordinates of this thing. And to do that, we need the inverse cell dimension, which we have, right? And then we need to, we've got how big the cells are, but we need the corner to start so that we're relative to the voxel in the first place. So we need to take the world position, and we need to take the world corner of our voxel. And now we've mapped it into that space, right? We then take the floor, and that gives us the actual coordinates. We don't care about this at all, right? This is just not relevant to us. Not sure what that means exactly, but because yeah, sure. And so then what we need to do is we need to clamp the results so that we're always snapped into the voxel, even for things that are outside the voxel, because we don't want to ever have a bad lookup, right? So in order to clamp it, we take our cell chords, right? And these are just going to be that. In fact, we could just call it that. And these coordinates that we actually produce, like, they can be negative now. So we need to clamp them, and they also could be greater than the maximum value. So we need to clamp these to what the actual values can be. And in order to do that, we need to know, like, what the maximum size of our voxel is. And we have that here, right? It's this value. So we just need to say, oh, well, you know, however big the voxel is, that's what it, you know, has to clamp to. Once we have that information, we can look up into the voxel using this and find out exactly what's in there at that point. And so we kind of now have the ability to do exactly what we wanted to do in the inverse mapping. So taking a point and finding out which voxel it corresponds to. So we've got that. What we don't have is the opposite. So some way of taking a voxel, when we're going to want this, right, to find out what the voxel center is. So what we want to do is have some reverse of this, which is like get voxel center P or something like that, that takes the lighting solution and one of the indexes and then produces the center point of the voxel from that. So in order to do that, we need to do exactly the opposite, right? So this exact thing has to go in reverse, right? We have to take the voxel cell dimension and multiply it by the index here, right? And so this has to get lofted up to a V3. That makes us spaced out correctly to be spaced the amount that the voxel cell dim is, right? And then we need to add the minimum corner into it. Now that'll give us the corner of the voxel, but if we actually want to know the center of the voxel, we need to add an offset, right? So in addition to doing the Handmade product on the whole indices, we kind of want an offset here of half of the index value so that we get to the middle of the voxel instead of the corner. This gives us a way to go in and out of voxel space pretty cleanly. So this should allow us to do a basic fill of our voxel grid to start with, right? So we're gonna do just some basic work with that now. In here, this provides us our ability to solve this problem here, not knowing what the x, y, and z are. So what I should be able to do at the start here is say, all right, let's find out what the voxel center is and the coordinates. So here's the voxel, let's call this voxel index or vox I maybe. So for the cast P, this is the location we cast from. This is the voxel thing. And so then the vox center P. Is just a lookup on that. So now when we do this, we have all the information we need. So this now, instead of z, y, x, is going to be just vox I.z, right? Vox I.y. Vox I.x. Now we can choose to do some other things here. We can choose, if we want to, this get voxel index. We could actually change this. And maybe we should. I don't know how exactly we want to do this. But what we can do here is say, if we wanted to, we could make this so that this thing would not record results for people outside the usable area, right? In other words, if we wanted to, we could make it so that only like the hot region was considered or whatever else we want. So we can pretty easily put an if in here and limit it. At the moment, I'm not going to do that because I don't really care. But when we actually start to think about this for real, there's going to be other things we're going to want to do there that are not the same. All right, so now we've actually got this coded. It's probably totally wrong, but at least we can start getting things going here, right? So let's see what happens there. OK, so off we go, right? And you can see we got some weird stuff happening here. But oddly enough, it's not totally wrong. So it's sort of doing something at the moment. And it's actually producing a little bounded light thing, which is pretty great, right? So we're off to a start, if not particularly good start, but that's totally fine, right? It's our job to now kind of get this into some better shape, right? So if we take a look at like what we're seeing here, you know, there's enough like curiosity in any one of these. There's enough weirdness. Like you can see there's like kind of weird like hard lines going through that for no apparent reason. Like what's that about? I have no idea, right? And so we kind of want to start looking at the actual casting now and figuring out what we're getting and why we're seeing what we're seeing, right? And the first thing I want to do is find out, like, did I do any of this right at all? Like, are any of these casts happening properly, right? So the first thing I'd like to do is take these light probe casts that we're doing. I'd like to go ahead and just see if those casts look reasonable at all, right? So I'm going to set is test case to 1. We'll probably need to restrict it more than we are currently in order to actually get usable results. What I could do is take the distance from the light, for example, so this. So I'll say like the test case is if Tmax is less than, you know, 10 or something, then that's a test case. Anything greater than that is not, right? And so that's just me attempting to bound the number of things that would be considered test cases in this case. And if I look now, honestly, it's a bit weird. It seems like it's doing the opposite of what I asked for. If the length of the cast is less than 10, how are these less than 10 but those aren't? Did I do something strange here? I'm going to turn off the... That's a bit peculiar, wouldn't you say? I would have expected to see the exact opposite thing happen. So I must be going a little bit crazy here. Oops. I mean, that's very strange. Oh, am I just not drawing things that don't hit? Yeah, maybe that's all. Could be that's all that's happening. All right, let's take a look. So it looks like I should be drawing things even if they don't hit, right? Because here's hit, right? And we're setting the line color based on it. But then I do this. I guess this part here may be wrong. So hit P is Tmax times cast D. Oh, yeah, that's totally wrong. That's the problem. So no, I was just coding poorly. Just coding poorly. All right. So here's our casting information, and I'll be honest, it looks great. That looks exactly right to me. I mean, you can kind of see it connecting up to all the points we actually wanted it to. You can see that points that appear to be, you know, probes that are like in weird positions. Like I don't know what the heck that cast is doing down there. Is there actually a light probe down there? Like what is that doing there? I don't really want to know. That seems busted. I wonder if we have a bogus light probe. That might just be like 0, 0, 0, and we'll have to address that later. But if you take a look at what's going on here, I mean, this looks great. You can see, like, as I'm going through this doorway here, you can look at the visibility of these light probes, and you can see that, like, these are blocked by the door, these are not, right? And so everybody is very, very consistent, in my opinion. Even this one here who can just barely see over it, you know, that was correct, right? So that all seems pretty good to me. So I'm going to go ahead and say it looks like our voxel fill is really the only problem, and there may not really be a problem with it. It may just not be complete enough yet. And I'll explain what I mean by that in a second. But that means really what I kind of need to see is not the casting anymore. The casting is not the important part. It's the voxel flood. So basically, the thing that fills this voxel in, I want to know which voxels we're filling. That's the important part now. And so we kind of have to get that going a little bit more. I don't know... to be completely honest with you, I also don't 100% know if this... So we're using the cast starting location to produce the index, which seems right to me. We're then taking the distance, the light source distance from the voxel center, and that all seems right. And then we're just saying if we hit, we don't fill it. And that all seems right to me. Yeah. So that all seems pretty good. The only thing that we're not doing yet, right, is these need to be kind of weighted additions, right? These need to be blended together, and they're currently not being blended together, right? So the main thing that we're really not handling at the moment is the fact that we have multiple things writing into the same location, and we're not doing anything about that. I don't think that has anything to do with the problem we're looking at now, but that is something that we're going to have to do going forward. All right, so what I want to do now is we have in our Raycaster a way of drawing a debug box, right? Using debug lines, we can draw a debug box. I don't really remember where I put that. Here it is. So what I want to do is have that be this push debug line. I want like internal void push debug box. And what I want to do is just take this code, this whole nonsense here. I want that to be callable elsewhere so that I can draw debug boxes in this debug system really easily, right? So this just needs the Ludding solution, and then it needs box min, box max, and then it just needs a color value, I think is all. And then it draws the box, right? All right, so the box min, max, and color here, those kind of want to be extracted. If you look at how they're being extracted here, we kind of need to do an extract component on them so that we don't have to pass them, that they can be passed as v3s and not as these sort of composite versions, right? So we want to do like a get component on these. Like that. And then I think that should give us everything we need. Now, this routine now needs to be like getting rid of the .e, right? In fact, I guess I can just sort of, I think I can just, yeah. So I can just remove that entirely because it should just be that, right? So now we can call that from anywhere as soon as I get rid of the compiler errors. Looks like there aren't any. So now instead of just being able to draw boxes inside the Raycaster, I can draw boxes anywhere, which is exactly what I actually need now to debug the next step, which is the voxels sort of filling, which may or may not be operating incorrectly right now. Like it may be correct and just incomplete because we haven't like bloomed out to neighboring voxels, which is something I need to be able to do. But I want to just get the simple, straightforward version and know that it's working properly first before we go down that road. So the first thing I want to do, yeah, is just verify that we're filling the voxels that we think we're filling. And so I'm going to have an if test case around here, and then I'm going to draw it. So in here, I'm going to say, like, look, if this is a test case, so what are the ones that we were trying to do here? I'm going to push debug lines on for the box. And I'm going to use this right here. So I've got my vox center P, so I'm just going to say, like, all right, I'm not sure what color I should draw this in, but maybe like something like this. And if we look at what I'm doing here, right, all I'm trying to do is say, when I raycast from these light probes, show me which voxels are actually getting hit, right? Because I want to make sure that that placement scheme is actually working. So the box radius in this case is pretty easy for us to figure out, right? It's just the voxel dim divided by 2, right? That's all I have to do, because I know that that's the radius of the box, so that's from the center. I would just go half in either direction, and then that gives me my box, right? It's complaining about something that's true. It's a V4. And so now I think we're good. That should draw what I wanted it to draw. And so let's go ahead and run that and see. Looks like maybe I'm overflowing. Maybe let's make this a little bit less sprawling. I have a pretty small buffer for debug lines, and not to mention the fact that we don't draw them particularly quickly, so. Seriously? Is that really true? Do I have a different bug? I wonder if I have a different bug here. All right. So let's start by saying Tmax less than 2. All right. So somehow that seems to be creating a overflow really early. And I feel like that means I've done something stupid, because it really shouldn't, I don't think. That feels really wrong to me. I feel like we need to take a look at that. Where are my debug lines? So I don't feel like we could possibly be drawing 4096 debug lines there. That didn't look plausible to me. I mean, it's only like, what, 12 lines per box? So I should be able to draw like easily 100 boxes before anyone thinks anything weird is going on, right? So is there some weird thing happening there? I want to take a look at this a little more carefully here. Oh, hey, Molly Bean. The puss arrive. She's just mousing around right now. She's not doing nothing. She's just like looking to see what the status of the world is. You know how cats like to patrol. What are you doing, puss? Hmm? You want to help us debug the lighting? Do you want to help us debug the lighting and all? Do you? You want to play with the paperclip? What are you doing? All right, that's coffee. You don't want that. Caffeine is bad for cats. All right. So yeah, let me just run this in debug mode, and I want to see like what that crash is about, because I don't really understand who is drawing so many lines here. So first of all, I just wanted to verify that was the case, but you can see that it is, right? So it's looking and it says like the debug line count is less than the size of this thing, right? So if we look at the debug line, how many of these there are, it looks like it actually got to 4096. And my question is, you know, how is it getting there, given how little there actually is, in theory, of drawing these debug lines? The number of debug lines we should be drawing is just not that high, right? So I'm a little confused about that. And in theory, the debug line count should have been set to 0 here. So like if we actually kind of go through here, want to see that value specifically. So coming into this routine, we have not drawn anything. And so presumably just running that is enough to draw 4,096 lines. Now, what's weird about that is it just didn't seem like there were, but maybe there actually are. I'm going to go ahead and up that number just because if that's really true, we just need more of them. And yeah, maybe it'll bog down our renderer hugely and it's a disaster, but you know what? Not my problem. All right. So let's see. Here is supposedly us drawing 4,096 lines. That seems totally crazy to me. I mean, I guess each one of these is 3, and each one of these is 12. But like, seriously? When you do push debug line, does it somehow like add more than it should? All right, I'm gonna do one more check because it just doesn't look right. Doesn't look like there's 4,096 lines, even with those multiples in there. Doesn't feel right to me. I mean, to be fair, drawing the same box on top of itself multiple times would, increase the count, and we are doing that. But like 12 times, what, 200-300 would have to be before we really were able to get up that high. It just doesn't seem right. So I just want to check to make sure there's nothing else weird going on. This is me just being paranoid. But sometimes when programming, it pays to be paranoid. That's a little suspicious, don't you think? Are we doing something where we have like a ton of light probes that are all set to the same value or something? Yeah, that is exactly what's happening. So this could also be just because the light probe stuff is putting the things in there at particular locations. So that's what's happening. So here's my proposal. I think that means I would like to get rid of the usage of the assignment slots at the moment. So here's what we're going to do instead. I'm going to go into the renderer here. I want to look at the light probe stuff. And in set light probe position, what we're going to do is we're going to nuke this out here. This is not what's going to happen here. Instead, we're going to have like a push call for that. So we don't want any of this light probe clear. We want none of this stuff, right? So we're going to say no to this. And instead what we're going to do is we're going to say push light probe. Render group, entity P. And all this is, the only thing this will do is basically ensure that there is a light probe at that location, right? So then we're going to take the set light probe position, and we're going to leave that in there in case I end up needing it, in case it turns out that this whole thing doesn't work. And instead what we're going to do here is, instead of all this, we're just going to say, assuming that we have room for it, then it goes in here. And that's it, right? So now we should get our light probes Did we not, should I rename that? So now we should get our light probes being like a clean, compact set, and we should not be having any two in the same location anymore, right? Now, unless there's something else screwed up, which for all I know there might be, but I want to, yeah, that's what I would have expected. So basically we just had a crap ton of light probes that really weren't doing anything, and that was kind of to be expected with the way we were doing it. But now you can sort of see, like, okay, everything's fine, right? And what you can see here too is, looking at the way that this stuff is working, you can see how the lighting information is getting placed, right? So there's a couple things that are kind of nasty about this. Our grid is not really centered the way that I probably would have hoped. Like, so we probably want to adjust the way our grid is working, so that it's offset a little bit. But that's a separate issue that we can deal with later. What we really want to do here is figure out why we're getting the weird pock marking that we were getting, right? So when we look at this, what are we actually filling? And I kind of want to shrink these. I think what I want to do here is, you see it was hard to see, like, once you get enough in an area, it's hard to see which ones are getting filled. I want to just use a very simple technique to make that visualization easier for us to understand. So inside the lighting, when we draw that box, I want to shrink it just a little. So basically what that's going to do is let me see which ones are actually getting filled, instead of what was kind of happening before, where it was very hard to see. Oh, and by the way, we don't really need to be in debug mode anymore. But so now what you can see is we can easily see which voxels are actually getting hit and which ones aren't, right? And that's, pretty useful, right? So what you can see here is it's pretty obvious why our pock marking is happening. And it's just because these are right on the boundary, so these middles ones never get filled with any information. Now, obviously, our sampling scheme is pretty crappy if that's what's happening. But it's okay, because actually we want to solve that problem anyway for separate reasons, which is that when we actually fill a voxel, we want to fill sort of a swath of 9, probably. A swath of 9 around the voxel. And that's something that we kind of want to do as a separate pass. And that's pretty crucial for, just for allowing this thing to work sort of at edges, I guess is what I would say, right? Where the light probes stop. And so in order to do that, what I'd like to do is just go in there and add a little loop that spams out to neighboring areas, right? And then we're going to very quickly get into the fact that this is not properly handling sort of summation, like contribution, right? But let's go ahead and do that part first. So when we get Molly Bean, that was the sad meows. Molly, where are you at? Come here, puss. Come on. What's wrong? Come on up. What's wrong? Do you want to code with us? Do you want to say hi to the camera? Come on, say hi to the camera. There you go, baby. Do you want to see the camera? That's the camera. Yeah. There's a bunch of people. There's a couple hundred people watching you right now. Did you know that? Yeah. What's wrong? Did you want someone to play with you and no one was playing with you? Is that what happened? Yeah. Is that what happened? Okay. Do you want to just sit with me, or do you want to, what do you want to do? I don't know what you're up to. You were mousing around before, so I have a feeling you don't want to sit. I have a feeling you want to play, but I can't play with you right now. When the stream's over, we can play. Okay? Is that okay? Is that all right? Maybe? What do you think? What do you think, kiddo? Maybe? All right, well, you can decide, but I just can't play right now, that's all. But you can sit if you want. You can sit on my lap if you want. We got room for you here. We do. If you're up for it. What are you looking at? Yeah, you're in a play mode, though. This is the problem. You're not in a sitting mode. I know you're not. I can see you looking over there. Here, you want to play. Go ahead down. Go ahead down. There you go. And we'll play later, okay? All right, so anyway, what I want to do is just kind of spam this out to nearby voxels as well. So I want this to kind of be a little bit of a for I loop, right? And so I want this to, do this kind of thing, right? So we do want our kind of like XYZ thing in here. And to be honest, I don't know if I really want it to look like a for I loop, though. And the reason for that is just because I don't really want to spin up an entire set of like loops and jumps and unpredictable branches and crap like this for no reason. So what I'd rather do is something more like this, maybe. So, maybe something that looks a little bit like this, where I do like, spam voxel or something like this. And that's going to take that voxel I, do all this garbage on it, and then spam out to the voxel. And so what I need here is I just need, I don't really need this part here because I can just not do the right. So this is probably fine. But what I do need is I need the light position, right? And of course, since we have that here, I can just, this is test code, so we don't have to be very specific about where that's coming from. But so we can do this stuff just fine. And the is test case part, we can just sort of inherit from our caller. I'm sorry, is test cast. And then I really just need to make this stuff get called with the correct set of voxel eyes. So the problem that we're going to have here is just that we could be outside the voxel now, so we kind of need some ability to clamp this thing. And so we need this to support that sort of spam radius in a sense, right? And when we do that clamp, we could just clamp it to the interior and then do the spamming. I don't know if that's a particularly good idea, but I'm just saying we could do it that way. But point being, what we need here is basically like a set of these. So we need like, this sort of thing. So all I want to do here is just spam a predictable set of these. Like so. And I feel like there should only be, oh wait, no, there's way more of them. So no, it's just 3 by 3 by 3. So there's actually 27 things it touches. That's too many. It feels like we really do want to not have to do this. Well, in for a penny, in for a pound. Anyway, so this is going to be expensive for us. We're going to probably have to figure out ways to make this work better, to be completely honest, because this is going to be pretty nasty in terms of the amount of work that's involved in sort of blooming the voxel. So we may have to do something more clever than what I'm doing here. And yeah, so if we look at like how this works, so let's suppose we did it this way. We would have to repeat this for each one of these, right? And so maybe we do have like one for I loop. And then we just spam the 9 case. So something like this is basically what we're looking at. And the problem that we're going to have is this is going to be out of bounds now, right? And so what we could do is say, well, when we do map into voxel, we'll just get rid of the clamp completely, right? So this part here, we'll just be like, good luck, right? So when you get that voxel index, that could be just totally out of bounds. And then when we do like our offsetting of it, you know, this will actually happen here. So we'll do a like if in large voxel, off we go. Otherwise, don't do anything. And then we just have, you know, something like this that can test for like insideness. And then we'll just not fill if we're not inside. So then we've got solution, box I, and I think at that point, we're good to go. Now, yeah, all right. I now want to see like what I'm actually filling. Hopefully we're filling a lot more stuff, and it looks like we are, right? And so now I want to see if that kind of takes care of the issue we were having with the, you know, the fill not spreading out properly. So if we're, you know, if we do that spamming to the things around the voxel, let's go ahead and see what the actual Z-bias program result looks like at that point. And so I'm going to turn off the lighting disabled and turn on the non-debug build there. And just see what kind of results we're getting. Let's see here. So now it looks like we're more or less getting what I would expect. And what you can see is the only issue now, right, is that we fill things that aren't really visible, right? So we're spamming kind of out to things that aren't quite visible. And I think that actually can be taken care of by a slightly different thing we can do as well. Although actually, you know what the only thing is? That may actually be because some of those are visible. Let's turn that off first to get a fair result. So I'm going to set the light source to be lower now, so that it'll actually be blocked by walls, because it kind of clears over the walls a bunch of times now. I just want to get rid of that while we're testing this. So if we go into what is it, debug light, yeah. So what I want to do here is take the camera NDP. I want to drop that light down a significant amount so that it's much lower down, maybe even lower down than +1, but we'll see in a second. So that's like right about the hero's head level. Yeah. So now it can't really clear walls. So that flood filling presumably is coming from, well, I'll be honest, I'm not sure who that's coming from. How is there a like valid light that's hitting that? So I'm not really sure what's going on there, because even that shouldn't quite have the light leaking bug that I'm thinking of at the moment. So let me take a look and see, because I'm not really sure what we're dealing with there before I start mouthing off about what I wanted to do about it, because I'm not really sure where that's going. Because yeah, like if you look at like that doesn't propagate through the wall, right? Like the light probe here is not going to write into that. So I'm not sure why you would ever be getting any light leaking through there, right? I need a way to see these both at the same time. So we're going to have to, oops, that's not what I wanted at all. So we're going to have to do some work on our debug setup. Maybe that's what we'll do next weekend in preparation for like doing the final light code, is we'll improve the debug viz on the lighting, because right now it's crappy. I just need a bunch of ways to switch things on and off so I can see. Yeah, so I don't get that. Like, I don't get who's actually filling that there. I'm going to set the radius a little higher so I can see some of those test cases and what they're actually returning. So if I go into the Frumbledegock routine, was the easiest thing to do there. So it's, what's the actual name? It's like test case castrum probes. So what I want to do here is maybe just spread this out a little more, so we can see like a little more what's going on in there. Oh, duh. We never put in the hit case. So, yeah, that was all just not even a thing. Boy, that's almost an owl of shame. Thankfully, I thought of it right away. That was almost an owl of shame. All right, so let's now figure out what the heck is going on here. So you can see here that for some reason, well, no, we're still getting some weird interpolation there. Oh, I see why. That's because we're not clearing the voxel. That's all, right? So you can see we're not actually updating the voxel in those regions. And that's because we don't actually clear, I'll just clear the voxel. We don't actually want to do that eventually. But I think now we're getting more accurate results, right? What is this? Looks like we've got too many quads getting pushed down. All right, so I think we're better now. I think we're in more reasonable shape. I'm going to turn that test caster down so we're not drawing so many boxes. But okay. So what I want to do now is just clear the voxel before we do anything else. And the reason for that is just because right now we're not really doing anything sensible in terms of like averaging over frames or anything. So stuff that goes into the voxel just stays in the voxel, and it sort of bogarts our results, right? So I want to loop over the entire voxel, which honestly I don't know if we have code that does that. Yeah, we do. So in crumbly-gock, we can go ahead in here and just clear the voxel first, which is not something we would ordinarily do, but it's going to be something we do now. And so I'm just going to literally clear everything in the voxel, all of the lights, and turn them off. That way, if you don't actually see one on a particular frame, then you don't, that doesn't actually work. That should show us a fairer estimate of the lighting. And you can see, like, when we hop up, sometimes it clears it. So I should probably still move the light down just a little bit more, right? But as you can see, like, it's starting to look pretty good. So I think we're now correctly sort of doing roughly what we should. I still think it's a little too high. So I'm going to move it down, because when we hop up, it's still kind of... What's going on there? Oh, wow. So that's too low. Then it can't quite clear the floor. All of this will be not really a huge issue once we're actually doing bounce lighting, obviously, but... Okay, so basically now we more or less have, like, fog of war, right? Like, you know, you can't really see until you actually get there. I'm curious to know what happens if we increase the fall off, right? So if I actually change the fall off of the light, which is, you know, just a nonsense thing that's happening in here right now. It's just this garbage here, right? So if I decided to do this as something more like that, so now the light falls off more slowly, that radius gets larger. What you should see is, like, you know, kind of just basically fog of war, right? The Raycaster is sort of telling us now, like, what you can see, right? So again, not really something we want to use for lighting per se, right? Because it's not actually telling us any kind of a good lighting solution, right? It's not telling us anything about, like, how the light bounces around. And so, you know, it's not what we want for any of that stuff. But if we go ahead and turn off the test cast thing, then you can see that we basically have a little fog of war solver, right? Which is exactly what a Raycaster does, right? It doesn't really give us lighting, but it gives us some, you know, sort of, it's a visibility query, right? And what we happen to be asking for is the visibility from the light source. And since I put the light source at the player, unsurprisingly, you know, that's what we get, right? You can see our kind of weird specular thing that we did there having an effect. So I'm going to call that good for today, for sure. Because the next step is now we have to kind of move on to kind of a whole another ball game of convecting light sources around and then merging samples as well, which is really not something that's going to be simple, right? That's going to be a whole another sort of set of things we've got to do. And you know what? Can I use the ground point of the entity, by the way, and so it doesn't... Where's the debug light P thing? Isn't there like a ground point? Nonsense. This is supposed to be more stable, I think. Yeah. So we're getting there, slowly but surely. And I think that Raycaster's working pretty reliably now from the light. Like that all seems pretty good. We still have a ton of problems with the sort of the. I don't like the flicker that you get. I mean, the lighting obviously is making most of the problem here, but the fact that you kind of blend things in and out based, like, you want the ground P to actually be a plane, so when you're hopping over uneven terrain, you want things like the alpha to stay the same. That's kind of a separate issue that we're going to have to do before I really consider the graphics to be solid. But the lighting's more important at the moment, right? So I would consider that pretty much working. And we now have the other two things. We have the blending and the convection now we got to start working on, but that's fine. So I think we're pretty good. Right, I mean that's working very well considering how we've really done nothing but a single raycast. So I think we're in good shape. Like I'm not too worried about this now. I think this is coming along. Also, unlike before, like this is running completely fine, very stable and per pixel, right? We're getting full lighting on everything, including characters and stuff like that. That we can now go in and like tune their normals and stuff. I mean, you can see like it's even working here. Like because the normals on that person are just pointing directly away from me, it gets no light. And when I come on the other side of it, it does, right? So we now have like an ability to sample lighting per pixel on all the sprites as well. So that'll give us a lot of flexibility to, I mean, we have to decide what we want to do there because it's kind of confusing how you want to light stuff like that. But, you know, it gives us a lot of flexibility on how we can choose to light our sprites as well, which is nice. Okay. Let's go to the Q&A. Isn't there an hour left? I don't think so. The stream started at 12:30, right? Would the particle system be affected by the shadows? Yes. Let me just take a look here. So, I believe it already actually is as well. So I don't really know, but everything, as far as I know, including the particles, go through the same shader. So it should be totally, yeah, you can actually see that there, right? So the normals are probably set wrong on the particles at the moment. So we'd have to set the normals, but you can see they are affected by the lighting, right? So all we really have to do is make sure for each particle we set the normal to something, right? And then we're good. So the particles should all work just fine. In fact, everything will work just fine. So mostly what we have to do now is make like a real lighting convection and then sample blending, right? Because right now, and you can kind of see, it's just discrete. Either you can see the light source or you can't. So you basically, it goes on one frame from being able to see it to not being able to see it, and that's what changes the lighting. So that's not what we want at all, right? And also we don't get any bounces, right? So that's not what we want. So this is just raycasting testing. So we gotta go and actually do that part, which is what we'll start on next weekend. But other than that, I think we're good, because now any sprite that we want can totally have that happen. I should also take out the, like there's no reason for the light probes to be drawn at the moment. Yeah. There's some issues with the smoothness, and that has to do with blending as well. I suspect. And I guess I'm not 100% sure of it though. So I'm not 100% sure what a little of that flicker is coming from, so we may have to investigate that a little further. That may just have to do with the blending not being in there. I'm not positive. Can we enable light for the debugger so we can see the impact of the code? Again, probably don't want to do that till next stream, because I think that's a fairly big thing. Am I procrastinating on doing gameplay code and event problems to solve? Yes. I mean, as I've said many times, I really don't want to have to do any gameplay code. I'm going to run out of things to do eventually, but I will make that be as far away as possible, because that is really not my thing, right? And I'm not looking forward to it. That is why I'm an engine programmer and not a gameplay programmer. I would much rather sit around improving lighting quality than having to code like what happens when you like punch a dude. You know what I mean? I feel like our lighting is going to look really, really baller. Once we get the bounce in there, this thing's going to look sweet. Yeah, I'm excited for that. Just give the game code as an assignment to John. Yeah, John doesn't have much to do. Why are the debug lines a fixed size buffer just because it's throwaway code? Yeah, I mean, it just doesn't matter, right? Also, kind of for the reason that we just saw, like, I want it to complain if I draw too many debug lines because that probably means something weird is happening. And it was. So, you know, sometimes you want some hard limits in your code, especially if it's not something that the user interacts with, because it lets you know that something went wrong. Do you have any thoughts on the trade-offs of making your data structures directly serializable versus having intermediate serialized deserialized steps, i.e. data structures containing pointers being converted to offsets or indices? So I guess what I would say is I don't normally think of it that way. Serialization is usually not that big of a deal to me. Because usually if your stuff is working well at runtime, it is usually trivial to serialize it, is my experience. So for example, you know, typically you don't really want pointers anyway in your data structures. Like if you have pointers in your like world code, it usually means something bad is happening, right? It usually means that like you're using a lot more space to store something than you probably should, which is going to make it inefficient, right? And so most of the time, I find it's not really an issue. So the question doesn't usually come up. Another way to say it would be that usually you've already converted things to offsets or indices for other performance or compactness reasons before you even have to worry about the serialization part of things, at least the way I write things. 0LPBM says, are the bounces going to be computed also with the ray tracer? Absolutely. That is exactly what's going to be happening. That's why we did it this way first, is so I could verify that direct lighting worked properly, because that's easy for me to inspect. Like I can tell that this is doing what it's supposed to be doing for the most part, right? And that the Raycaster isn't, you know, confused about something. And we can test it some more using this as an example, right? You can see there's some weirdness there where like we clip off the lighting's getting like clipped off there. I don't know why. Maybe because of the close enough filtering. In fact, I can check that right now. Yeah, so if inside the Raycast we are still doing that, which we are, yeah. I'm kind of wondering if this is nonsense, right? So the close enough filtering I've already said is kind of a to-do because I don't think it's very good. I just want to see if that's what's happening here. Yep. So that close enough filtering is like garbage. And that's unfortunate, but yeah, that's where we're at. So that close enough filtering probably needs to be done differently. However, just increasing the total distance was enough to fix it here, so I suppose it's not an immediate concern, but I do think it's just generally kind of wrong. Can we add for a test a second bounce, or would it require more work? For a test, we could add a second bounce. It would not be being done the way we will do it in the future, though, right? I'm trying to think if really it would even do anything at all. I mean, so if we were literally just hacking that in, right, to the way that it's working currently, and the problem is we don't have blending either, so I really don't think this would be an interesting test, to be completely honest with you. Oops. Like, I don't think this is going to be useful, but if you needed to hack it in this way, what you would have to do is basically right here where we find out that we got a hit, we then have to like recast to see if there is a non-hit from the other point, and then we have to decide like how much to attenuate, which I don't actually know exactly how we would do. I guess we just take the total distance or something of travel, but yeah, I mean, I don't know. Like, this is not at all right, but that's what you would do. You'd go like, all right, you know, if we hit, do it again. Where we would basically say like, yeah, you know, where the hit people, I don't know why there's an if one around this anymore. That was just kind of stupid, but so we'd say, yeah, all right, you know, the place that we actually hit, we need to produce a new casty for that's going to come from like the direction, the new direction to the light source, right? So you'd have to do this whole stupid thing again, right? So you'd say like, all right, the secondary cast direction is like the direction from the hit P, and the secondary cast Tmax, right, is this, or that, who knows. Right? So you would do that, and then you would have a secondary cast that would tell you whether or not you hit. If you didn't hit, so if like you did this, right? Or rather, that. So if you cast and you didn't hit anything, then you could undo the hit and say like, no, it's not. And the problem would be that we would need to be passing to the spam voxel the fact that it should be dimmer, because it had to bounce, right? So I don't really know that this is going to do anything that we want done. Why am I not able to build my code? What's going on here? Oh, no, it is building the code. Never mind. So, you know, in theory, I guess, that maybe is doing a secondary bounce now. I mean, again, I don't really know how to even verify that in any particular way, but it kind of does look like it's doing something slightly different. I mean, we can certainly test at least whether or not the thing works. You know, like whether it does anything. So if I just zero this out here, I can't see anything. I if it in, and like those things can see the secondary bounce, right? But it's like, I mean, it just means like someone, like someone over here hit that and then could like, or someone over here like hit that and was able to get there or something, right? For whatever reason. But it's not a true secondary, it's not secondary light distribution because it doesn't take into account the fact that like all of these surfaces got some light, like these surfaces could get some light or something and then they could spread it out, in all directions. So it's just a specular bounce. So it doesn't mean anything, right? It's just not useful, I don't think. It doesn't improve the quality in any meaningful way, right? Whereas the distribution system we had from before, when we turn that on, I think that'll be a big difference, right? Because it actually is taking account infinite bounces basically and proper like spreading of the light around. So let me make sure I didn't screw anything up there. Yeah. Do you plan on any details on how sprites are lit? Yeah, I'm not sure what we want to do with sprite lighting, but once we have the lighting solution correct for the 3D geometry, since we can sample it per pixel now, I don't think it's going to be particularly hard to come up with a reasonable sort of hacked function that gives us the lighting we want, and we can sort of play with what that means. It's not going to be something physically realistic at all, but it will be probably something around like interpolating the normals such that they capture kind of roughly the lighting we want. It's my second year programming and it feels like there's endless stuff to catch up before I can be a competent game programmer. What might I do to help with that? Yeah, I mean, that's just true, right? It takes a lot of work before you can be a game engine programmer. And that's okay, right? It takes a while. When you first start working in the industry, you're not going to know everything, and that's fine. It takes several years to kind of get up to speed on all that stuff. So you just want to focus on one thing at first, maybe you start by doing, I'm just doing some physics, or I'm just doing some graphics, or I'm just doing some this or that, or architecture stuff, or entities work, or gameplay programming work, right? And you just build outward, one thing at a time and take it easy, Nobody knows everything day one. It takes many, many years. And that's fine. And you're not going to be expected to know everything the first day you show up at your first game programming job. So, I wouldn't stress too much about it. But always be programming. ABC, right? Always be coding. And if you're always working, eventually that knowledge will just build over time. Oops, sorry, Valbus, did I mess something up there? Maybe I didn't do a fair test of that. I mean, I still don't, it's just not useful, but was there something messed up in here? Oh, yeah. I did. Sorry. I think that's right now. Again, I mean, not really testing it. I don't know to what extent it's actually doing it properly, but in theory, that's a secondary bounce. I don't really know if it is. Doesn't seem to actually be doing anything. Oops. That's why. So there's without the quote-unquote secondary bounce. Kind of does what you'd expect. Here's with the not very good secondary bounce. And you would want some dimming in there, right? I mean, so to make it even remotely an interesting test, you would need to sort of have the total distance. So like, you would have to have something that let it know what the mitigation distance was. Like, and you'd have to like basically fake the light information. So this would have to update like the light P, right? So, you know, an example would be like, so inside spam voxel, this stuff here, so light P and also light C, right? So these would have to be things that come in, like, so we'd have to do this, like V3 light P and V3 light C. So basically, you'd be doing this. And then when you do spam voxel, you're actually passing down like this. And again, I really don't think this is even remotely related to what we should be doing, and we're not going to do anything like this next weekend. But just, you know, for the sake of completeness, if we were going to update the light P and the light C, right, then what we would do is say, okay, when we come through here, the light P is going to get read out of this, right? And the light C is just going to be a generic light. And then when we come through here, what we're going to do is say, all right, if we have a secondary hit, so we need to like update this light source to something else, then we're going to say the light is actually now technically coming from a different location. So the actual location the light is coming from now is the hit P, right? So where we actually bounced off of, that's the new light. And the light color is actually going to be whatever the attenuation would have been at that point, right? So that means the actual, like, this crap here, right, this thing, needs to be computed for fall off like this based on the distance of the original cast. So this thing, right? So the original cast distance that we actually traveled, whatever that was, needs to attenuate the light source first, and then that's the actual color that you get, right? And that's a totally hacked in nonsense thing. I don't even know if I typed it in right, but you get the idea, right? And so that dimming step wants to be there as well, and now you can kind of see what that looks like, and it's quite a bit different, right? Especially like out here, right? So it's probably super buggy, right? Like I don't know. This is probably not really correct. But it's something like that, right? How are you going to handle bouncing up different materials? So we have parameters in there right now that sort of allow you to say some things about the materials, but what we don't have is any way of like doing multi-textured stuff, and I think I'm not going to do that just for speed purposes. So probably what we'll do is cubes will just have a color per face, and we'll just use whatever color face you bump off of. Or we may even not do that. We may just say, look, cubes have a general attenuation, and that's all you get. So you basically just have, you know, here's the rough attenuation. Is it brown? Is it green or whatever? We're not going to really do anything more than that. Which type of engine programming do you think the industry needs the most? I mean, I don't know. I couldn't say for like the industry as a whole. I would say, based on what I see the need for, definitely need graphics programmers. You pretty much never run out of need for graphics programmers. There's always so much freaking graphics work to do. Pipeline programmers, so people who know how to like do like processing of assets and world LOD generation, chunking things up, constructive solid geometry. So basically, like people who geometry processing people. Tools construction people, so people who can make like little tools to do stuff or like user interfaces for things. We need a lot of that. There's just so much stuff. Optimizer people are typically very useful. Who can analyze the system, find out what's causing the problems, and go in and fix them so that the thing runs smoothly. Everyone needs those people. Generalists are useful everywhere. I mean, there's so much anything. If you can do any game engine programming, there's probably a place for you because there's so few. There's just nobody who does it. You know what I'm saying too. So I mean, that's just how it is. Yeah. The answer is everything everywhere, yes. Kind of, yeah. I mean, for example, right now I am trying to fill at least 4 requests from friends of mine looking for low-level, engine programmer quality people. And so far I have failed to find it. Question. Are engine programmers really as in demand as you say? I see the most AAA games are releasing with hundreds of employees, but only like 4 to 6 engine programmers. So here's what I would say. I can't tell you industry-wide because I don't know how to get that statistic. But I'll say 2 things. One, just personally, I can never find enough. Like I said, literally right now, if I had 4 high-quality engine programmer people, I could place them all in jobs immediately. I have no idea where to find them. None whatsoever, right? As for the statistic of like AAA games releasing with hundreds of employees but only like 4 to 6 engine programmers, first of all, I think that's not actually accurate. But in general, I would suspect that most of the time the reason there are only 4 to 6 engine programmers anywhere is because that's all they could find. I mean, I don't know where I'd go to find more than 6 engine programmers, period, like to hire right now. I can't even find 4, right? So, I mean, I'm just going by what I can't find. Whereas if you just want some random person who can write a script in Unity, I mean, I think you can just walk onto the internet and you'll trip over one, right? How much do game studios hire interns? I don't really know. I feel like Ryan Fleury, the person who now runs Handmade Network, who took over for Abner, I feel like he has interned at a couple game companies, or at least one. He interned at Insomniac, I think. You maybe want to post on the Handmade Network Discord or something. I don't know how you get those set up exactly, but Following with the theme, what do you define as the minimum requirements to be a good engine programmer? So the requirements for being someone who's would be useful on an engine programming team, I would say I'd have to think about how to define it specifically, but it probably is sort of a three-pronged test for me. One would be gets a lot of work done, right? And this can fall into one of two categories. If you're an architecture guy, it means getting a lot of code actually done, because like writes and rewrites are your bread and butter, and you need to get a lot of this done. But if you're not, if you're an optimization guy, it may be a lot more targeted. So maybe you don't get a lot of code done, but you do a lot of work analyzing, figuring out problems, and you get through that cognitive work a lot, right? And so either way, you're producing a lot of very usable work frequently, either a lot of analysis or a lot of actual code, but you're producing a lot. You're not just sitting around talking all the time or hanging out on Twitter, right? So that's super important. That's the most important requirement really for any programmer, is you get a lot of work done every day. Number two would be comfortable with doing programming in C or C++ or assembly language routinely, and you do it clean and well without a lot of fuss. Not a lot of std : nonsense, none of this like modern C++ RAI nonsense, like none of that, right? Just actual sensible code that's simple, easy to read, like you see on Handmade Hero, just basic stuff, does what it's supposed to do, not all this ridiculous nonsense where somehow it takes you 10,000 lines of code to copy, a field from one place to another, right? And third would be, and this is the biggest difference, I suppose, between game engine programmer and just good programmer, because the other two things were the good programmer part. That is being comfortable researching and exploring new areas in sort of technology, right? So like what you see me doing with the lighting, I need you to be able to do experimentation and be comfortable like reading some research papers on something, like integrating that knowledge in, like, right? Being comfortable, being given tasks you don't already know how to do, right? That's really what I would say defines a good engine programmer for the most part. Would be mostly those three things, right? Why aren't most studios willing to compensate appropriately in spite of the seemingly short supply of graphics programmers? I guess, what do you mean by compensate appropriately? I mean, these are positions where you get paid well over $100,000 a year. I'm not sure what you mean by compensate appropriately. But I mean, graphics engine programmers, or like the positions that I would be thinking of filling would be positions where you would that would be paid a lot more money than, this is not a $50,000 a year position that we're talking about, right? Have you heard about Valve's ACO Mesa shader compiler for AMD GPUs? Apparently it is replacing LLVM and is a great thing for Linux gaming. I have no idea what that means. LLVM, what does that have to do with shader compilation? Anonymous, relative to other positions on the team that may not require as extensive knowledge. I mean, yeah, again, I just say, is that true? That doesn't sound right to me. I mean, at least, maybe my knowledge is old. But the difference between like a Unity scripter and a person who knows how to do graphics engine programming is like, over 2x salary, in my experience, right? I mean, none of this makes, I mean, if you're wondering why compensation doesn't make sense across companies, then that's sort of a separate issue and probably the broader question. It's because games don't make enough money, right? You could be the very stupidest, least good person on your game, on a game development team, and be like the smartest person, best programmer at like on a Google team, right? The level of expectation of being able to do stuff is like not, there's an arbitrage thing there, right? So those salaries are definitely not commensurate. You can definitely leave your game job and go get a Google job and be paid vastly more money for the same level of skill. That's just true. And that's just because, games have to actually compete on something, whereas, if you're a monopoly and you're unregulated by the government, it's unsurprisingly not hard to extract a lot of money from an economy, right? So that's just like unfortunate sign of the times. I don't think that'll be true in 20 years, right? But for now it is. Yeah, so I'm probably gonna wrap up the stream now. But yeah, sorry, I don't understand the ACO thing. So I don't know. I mean, like, yeah, I guess what does that have to do with Linux gaming? Is that just because the drivers on Linux are bad? So if you have a better shader compiler, like the games get better, or something? I don't quite understand. I understand the concept that maybe you can use LLVM to compile shaders, or I don't really know what you're talking about exactly, but like I just don't understand what this has to do with Linux gaming, right? That's the part that's throwing me for a loop. Is it just because like the drivers on Linux can't compile shaders well, so they perform poorly? I guess maybe. Anonymous. As a specific example, take Bethesda. They paid gameplay programmers 80 to 110K, but the graphics engine programmer is 90 to 130K. Obviously, those numbers are from Payscale, Glassdoor, etc., but most likely represent a decent sample size. So I would say two things about that. One is I don't know much about Bethesda, obviously. But what I would say is it also depends on what you mean by gameplay programmer. So if we're talking about someone who's actually programming real gameplay code, not in like a scripting language that actually involves a bunch of like tech stuff, they're not that different from a graphics programmer. So I wouldn't expect those two things to be really all that different, right? So it really depends on what you're talking about there. The other thing I would say is that salary range for a good engine programmer seems pretty low. So it may just be that Bethesda doesn't care much about engines for all I know, or maybe that's not really what that means, right? So you have to kind of be careful about looking at those numbers and what do they actually mean. Similarly, if you look at that range, if gameplay programmers are making 80K if they're scripters and engine programmers are making 130K if they're good, that actually is a very large difference, right? That's a 50% salary increase between the, it's more like a 60% one, right? So again, don't really know what that even means. It's hard to compare. But I would say like good engine programmers can make a lot more than 130K depending on where you go. And Bethesda may be a bad place to go for that because maybe they just don't care about getting more people with those skills. I don't know. I don't really have much insight into their process, right? All right, I'm gonna wrap it up. And also just to give some more data on there, like I said before, I've had people who are trying to staff up studios right now literally tell me that, engine programmers they have tried to hire end up getting jobs at Google, which is their biggest problem right now, or Facebook, and they get paid absurd amounts of money apparently. Like $130,000 is a laughable amount compared to the amounts that I heard quoted. And like I said, I don't know, I don't study this stuff, but I guess I would say I would think of it more as a problem in that direction. It does seem like there's going to be some leeching going on there because apparently game programmers are somewhat in demand because they know how to actually write stuff instead of just like writing in PHP or something. Or Python, I should say, if it's Google. All right. Thank you, everyone, for joining me for this episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow the series, you can always pre-order the game on handmadehero.org, and it comes with a source code so you can follow along with it. I will be back here next weekend, to try putting in a more real lighting solution. We already kind of have code that does that, but we haven't really gone the extra step and made that code sort of run on top of our new voxel system. So now that we sort of have some confidence that our voxel system is interpolating properly and we have some confidence that our raycasting is working properly, we can now combine those two things together and start to produce a system that will actually give us more subtle, more interesting lighting. And there's two steps to that. I don't know which order we'll do them in. One is we got to come up with a good blending solution for how do we actually output the lighting in a reasonable way. But the other thing that we're going to have to do is then re-enable the bounce and caching of the results over frames. Both of those things we have to do, so we'll take a crack at one of them next weekend, and we'll go from there. That's it for this week. Hopes everyone has fun programming this week, and I'll see you on the internet. Take it easy, everybody.